Hello and welcome to another video on discrete random variables. The last video kind of gives you an idea. The last two videos gives you an idea of how they're set up and a quick example. But these are just more examples just so you can see more practice. Okay, you will have both formulas on your formula sheet. Okay, on how to find the mean. So mu of x, you'll have this formula right here that will use the summation notation, and then they'll say xi times the probability of xi, and all this means is this is the random variable times the probability, then add with the second one, add third random variable probability times add, and the standard deviation will be there too, which we'll go over. So let's look at the first one and see if this is discrete. Let's see if it's a random variable, and then we'll see if it's discrete. So is the number of eggs broken in a half dozen carton of eggs. So you have 6 eggs. And 1, 2, 3, 4, 5, 6. You open it. You open it, okay? And you say, how many are broken? So the random variable is the number of broken eggs. And it's a y. So this is the probability of y. So you need to think, what are the outcomes possible? What could possibly happen? You open it and you look at it, and the random variables are the number of eggs that are broken. Okay, so there's more than one possibility. For example, you could open it, and what do you want to happen if you're buying these? Okay, so if you're buying these eggs, it would be great if you had none broken. Okay, but oftentimes, as you know, you open it and you look at all of them, and one might be broken. What's another possibility? Two might be broken. 3, 4, 5, and the most that can be broken is 6. You can't have more than 6 broken eggs if there's only 6 eggs to begin with. So there's 7 different outcomes. Okay, and I'm not going to find the mean, but I'll just put some sense to this. Which one do you think is going to happen the most? Okay, which random variable do you think will have the highest probability of happening? And I will say 0. So I'll say there's an 85% chance that when you open that none are broken. Okay, then I'll say there's a 10% there's a 10% chance that one's broken. So I'm at 95 right now. Okay, so now I'm going to say there is a 3% chance. Okay, so that's 85, 95. Now I'm at 98. I'm going to say there is a 1% chance. I'm at 99. Now this would be the rest. 99, 99 and a half, and this would be the rest, split in 2. Okay, so I could do this. You could just add all these up, minus 1, and then divide it by 2, and just plug everyone in there. I don't want to do it. Okay, so let's look at this. Let's set up our probability table and see if this is a discrete random variable. Let's see if we can put it in a table. Is the amount of 1. So you don't know the setup of the fundraiser. So I'm going to do the last one. So they're going to give 0 if you lose. They're going to give 5, and they're going to give 1,000. Okay, they're going to give 1,000. Okay, so they want to get 10,000 people to play. Okay, so for these 10,000 people that are going to play, one person is going to win the $1,000. Okay, so there's a 1 in 1,000 chance, a 1 in 10,000 chance, right? 1 in 10,000. Okay, they are going to have, this is a win the 1,000. Okay, this would be, you lose, so this would be $0, and I'm going to have 9,000 people. Okay, so if you have 9,000 people that are going to lose out of 10,000, so that's 9,000 out of 10,000. Okay, and now the rest of the people. So now total I have 9,001 people. Okay, and this has to be win $5. This is win $1,000. One person's going to win 1,000. 9,000 are going to lose, and five people, and not five people, but so many people are going to win this. So this would be not what's left over to give me 1,000. Okay, so that's going to be 999. People are going to win $5. Okay, so that's my probability. So remember, Z is the amount of money you're going to win. So if you find the expected Z, you're finding the money that you're going to win per play. Okay, so if you're playing this game, you do not want to pay more than that you're expected to win. Okay, so let's just go ahead and find this. The expected value is 0 times 9,000 over 10,000 plus 5 times 999 divided by 10,000 plus 1,000 times 1 over 10,000. Now if you look at this, which one is going to be weighted the most? Weighted the most. Well, the one that's weighted the most is this one. So that's going to pull this weighted average down close to 0. It'll be more than 0, but it'll be close to 0, you know. Okay, the next is this. So this needs to be weighted to less. How much is this 1,000? Think about it, this 1,000 is a big number. But it's really not accounted for that much because only 1 out of 10,000. That's a really small chance. Okay, so let's get out my calculator and see what this is. So I don't have to do this one because it's 0 times the number. You do have to do it with standard deviation, but not that. Okay, so 5 times, I'm just going across here, 5 times 999, enter, divided by 10,000. Okay, so that would be, I'm not sure if my calculator will carry these, so I'll write them down. Okay, so this is going to be 1, 2, 3, 1, 2, 3. I think this is just going to be 1 over 10. Okay, which 1 over 10 is just 10%. Okay, but let's just do it anyways. Okay, so 10%, 0.1. Okay, so it's 0.04995 plus 0.1. So you're expected to win, I'm just going to round that, it's money. You're expected to win 15 cents per play. Okay, so if you were going to play this game, you wouldn't want to pay more than 15 cents. Okay, that's how these things work. They're expected, you know, you winning money means they're losing money. So if they charge $1 to play, if they charge $1 to play, but how much are they expected to give? How much are they expected to lose? Because you winning is them losing. So they only lose 15 cents. So if they charge $1 to play, they're going to be making 85 cents per play. They're making 85 cents per play. So if they get 10,000 people to play, okay, that's times, because they're going to make 85 cents 10,000 times. Okay, so my brain's not working, but if you do 10,000, you just have to move the decimal over. I'll just do this so I don't make. So you're going to make $8,500 if you're the PTA, and if you get 10,000 people to play. Okay, so I'm not going to do this one out, but I'll just write the possibilities. Okay, so if you toss a coin 3 times, random variable x is the number of heads in 3 tosses. Okay, so the number of heads in 3 tosses. Okay, so it's not heads, heads, heads. These have to be numbers. So if you toss it 3 times, can you get no heads? Yes. No heads means all tails. All tails. Can you get one head? Yes. This would be 1H, 2 tails. Can you get 2? Yes, you can get 2 heads, 1 tails. Can you get 3? Yes, that's 3 heads. Okay? So it's very simple to find these probabilities. You should be able to find this one, and you should be able to find this one from what we've done already. Because the probability you get all tails is just 0.5 to the third power. The probability if you get all heads is 0.5 to the third power because they're independent. Okay? That's a heads, and a heads. Probability of all heads would be 0.5 times 0.5 times 0.5 because they're independent events. You multiply them all. So it's 0.5 to the third. Okay, same thing for the other one. So that's it. Thanks for watching.